Hello, ladies and gentlemen. We are looking right now at the seventh day of our topic 14 notes. I know it's been a long topic, long unit, but we've got it together pretty well so far. I think we can finish strong here. All right. In fact, this lesson and the next lesson, 14.7 and 14.8, are going to be the last two sections of notes for this entire school year. So let's get after it, okay? You will recall in the previous lessons that we talked about a cylinder in terms of how it relates to prisms. And we said that for all intents and purposes, when you look at all the formulas and how you solve for the volume and surface area of a cylinder, we said that it is basically just a circle prism. Okay? That idea also applies to what we're looking at today, which is cones. Okay? A cone, for all intents and purposes, when we look at these formulas in particular, is just a circle pyramid. Okay? In fact, this formula right here for the volume, 1/3 times capital B times H, is exactly the same as the formula for a volume of a pyramid. The only difference here is that instead of talking about finding capital B as the area of a triangle or the area of a trapezoid or a rectangle or whatever it is, instead of doing that, we are always going to use this formula for capital B is going to be pi r squared, okay? And that's because on a cone, on all the cones that we're going to be talking about, the area of the base is just the area of that circle down at the bottom of it. All right, so that's what we're going to use for capital B on all these problems. And you'll see that once again, the only two things that we actually have to plug into this formula are the r, the radius, and h, the height. Okay, so on a cone, just like on a pyramid, the height of the cone is when you go from the vertex and you drop straight directly down through the middle of the cone down to where it touches the base. Okay, that would be your height. So let's take a look at this first example. Okay, this first example, we've got a cone with the with all of the values given. We've got a height given and a radius given, and we're going to find two different answers to this problem. Okay, first one is going to be the exact volume. The exact volume is just like we talked about. You know what? We have not yet talked about it. Excuse me. Okay, whenever you see that word exact volume, that means you're going to keep your answer in terms of pi. Okay, exact volume is keeping the answer in terms of pi. An approximation of the volume is where we would include pi in our calculations and get a decimal answer rounded to the nearest tenth. So we'll keep it at one decimal place. Okay. So the two things that we need to plug in to this formula are the capital B and the height. So our capital B, remember that capital B is always going to be pi r squared when you're dealing with a cone. Okay. So pi r squared, we look at our radius, which is 3. That gives us pi times 3 squared. So our capital B is 9 pi. This capital B, this 9 pi is what's going to go in right here. So 1/3 times 9 pi. And then our height, given right over here, our height is 7. So 1/3 times 9 pi times 7. You can do it in little chunks and simplify one piece at a time. We end up with our volume of 21 pi cubic centimeters. Okay, that right there is our exact volume. 21 pi. Okay, if we were doing this in a calculator, what we would do, the calculator will turn on, let's see. What we will do is if we're finding our answer in terms of pi, remember that we're doing the calculations with all of the numbers except for pi. So we'll go with 1/3 times 9 times 7. And you can see that that gives us 21. So that means 21 right here would be the number in front of pi. Okay, so 21 pi is our exact number. Now, if we're looking for a decimal approximation, we literally are going to type in 21 times pi. And we see that 21 pi is equal to 65.97. Well, if we're rounding to one decimal place, that's actually going to round it up to 66.0. So that's our decimal approximation right there. All right, go on to this next one. A party hat is in the shape of the cone and wants us to find the volume of this party hat. All right, so we've got our formula for the volume, 1/3 capital B times H, and we know that capital B is always going to be pi r squared when you're dealing with a cone. All right, so we plug in our radius of 6. It becomes 36 pi for capital B. Our h that we're going to plug in is 14. That's the height of this cone. All right, so that's 1/3 times 36 times 14. In your calculator, you can literally set it up as 1/3 times 36 times 14. Okay, that's one way to do it. That'll give us, oh, oops, I did 13 instead of 1/3. Let's try that again. 1/3, there we go, times 36 times 14. Let's try that again. That's a little more like it. Okay, we do all of that simplifying, and it's 168 pi. That would be our exact volume, 168 pi cubic inches. If we're looking for an approximation, the approximate value would be 168 pi. And whatever 168 pi is equal to, 527.8, that's what we're looking for, 527.8. All right, that would be our approximation. Okay, we're going to skip that problem. We're going to go on to this one. I want you to pause the video and give it a shot on your own. All right, so the capital B that we're going to plug into all has to do with the information that it gave us. Take a look at this. They tried to trick us. They gave us a diameter instead of a radius. So we have to recognize that if the diameter is 7, that means the radius down here is going to be 3.5. So our capital B is 12.25. We plug that in. We also plug in our height of 9. When we multiply all that out, we get 36.75 pi. Okay, that would be our exact answer. 115.5 would be our approximation. Now the question is, does this 115.5 answer the question that's being asked in this problem? And the answer is no. Okay, because we don't want to know how much does one of the glasses hold. We want to know how much would it be if she fills 3 of the glasses. So we got to take our answer and multiply it times 3 to get our final answer. Okay, this is the one we were looking for. Okay, this is going to be something to look out for, because on a quiz or a test or even an assignment, you need to read very carefully and make sure that you are answering the question that's being asked. I guarantee you, in a multiple choice format, this right here, this 115, would have been one of the choices, and it would have been wrong because it doesn't answer the question that's being asked. Okay, the question that's being asked is about 3 of the glasses. So be on the lookout for something like that might try and trick you. All right, we're going to skip that problem and go right on to the surface area. Okay, I want you to go ahead and fill in these blanks right here. And I'll try and, I'm not a huge fan of the way that some of this stuff is worded, so I'll try and clear it up a little bit as best as I can. Okay, if you take a cone and you slice it down the slant height, okay, the slant height on a cone is just like the slant height of a pyramid. Instead of dropping the height directly from the vertex down straight through the middle of the pyramid to the base, the slant height on a pyramid was going down the middle of one of the faces. Now, we don't have a bunch of triangular faces on a cone the way we do on a pyramid, but the idea of the slant height is still the same. Okay, it's the height directly from the vertex at the top straight down to the edge of the circle that makes up the bottom base. Okay, it's down the outside. That's the important part here. Okay, because the slant height is what you use for the surface area. Okay, so if you ran a slice down the slant height and unrolled it and flattened it all out, it would look like this. It would look like part of a circle. Okay, that part of the circle is where these formulas come from. Okay, so down at the bottom of your page, this is the important information. To find the surface area, we find the sum of the area of the base and the area of the curved surface. Okay, the area of the base, the first part, is pi r squared. The second part, the area of the curved lateral surface, is pi times r times L. L is your slant height. Okay, so we find the area of the circular base, and then we find the area of the curved part that has the point on top. We add those together, and that is your total surface area. However, something I want to point out here is that just like in pyramids, you have a difference between lateral surface area and total surface area. Okay, I want to point this out because this formula right here is only for total surface area. Okay, this part is the base. That's your capital B, you may remember. And this other part over here, pi RL, that's the lateral area. Okay, that's your lateral area. So we've got the base and we've got the lateral area. So part A, when part A asks for the exact lateral surface area, we're only going to do this second part that I circled in blue. Okay, the exact lateral surface area is just pi times r times L. So it's going to be pi times 5 times 15. Remember, if we're looking for anything that's exact, we're keeping it in terms of pi. So the only thing that we actually type into the calculator here, the only thing that we're actually going to use the calculator for, if it'll turn on, is 5 times 15, which is 75. Okay, so 75 pi is what we're dealing with. 75 pi. There we go. 75 pi. All right. So part B is finding the total surface area. The total surface area is that pi RL that we just found, that 75 pi, plus pi r squared, which is pi times 5 squared. All right. So it's going to be 25 pi plus 75 pi. In total, that's 100 pi. Okay. That would be our exact surface area. And if we are doing this in finding a decimal approximation, it would be literally 100 pi. You just type that into the calculator; it'll give you a decimal approximation. If we round that off to one decimal place, it's going to be 314.2. All right, there's your surface area. This next problem, we're going to skip it. I want to go on to this one. This is going to be our last one for today. Okay, a cone-shaped roof has a radius of 14 feet and a slant height of 17 feet. The roof is completely covered with glass, and then it gives us a cost of the glass per square foot. Okay? I want you to think about this problem. Okay? You can see it on the screen. This yellow square, that yellow panel that I'm about to pull back, says lateral surface area. And I want you to think about why we are dealing with lateral surface area instead of total surface area on this problem. Okay? Think about the situation. You are putting a cone-shaped roof on top of a building. Okay? What is going on at the base of that cone? Well, if you're putting a roof on the building, the base of that cone is the building. Like it's inside of the building. Okay? We are trying to figure out how much it would cost to cover the outside of that roof, like the cone-shaped slanted part of that roof that's exposed to the outside. Okay? We don't care what's going on underneath the roof. We care what's going on top of the roof because we're covering it with glass. Okay, so we are only going to be dealing with lateral surface area because the base of this cone isn't part of the roof that we're dealing with. So pi RL is going to be our formula for just the lateral surface area only is going to be pi times r times L. So that's going to be pi times 14 times 17, which is 238 pi if you type that in. And 238 pi is equal to 747.7 feet, approximately. Approximately 747.7 square feet. Now, the reason we want to get a solid number of square feet is because of this last part, okay? The question is asking, what is the cost of covering the roof? And it gives us a price per square foot, okay? Since it gives us a price per square foot, we're going to multiply this 747 times that cost. And that gives us our total cost, which is a lot of money. It ends up being almost $30,000, y'all. Okay, so that's going to be all that we've got for this section talking about cones. We will finish up the section with our last lesson about spheres, and then we'll be done. That'll be all of the notes for topic 14, all right? So y'all have a good one and take care.